Hi everybody, welcome to a new video in Learning Tableau. This video is very important because it will not only cover how to apply these concepts in Tableau, but first to understand the concepts of join, relationship, and union. This is not only important for Tableau, but also important in data analysis in general. Also in this video, we will go back to remember a concept in data analysis and link it to the concepts that we have today. Today's video is divided into two sections. One will be theoretical to understand the main concepts and to understand the whole process and the importance of every one of these three concepts and why they are important. Then we will move to Tableau to work on them from Tableau. The video will be a little bit long, but it's very important to finish it all together. It's better to understand the theoretical part and then directly follow to the practical part to keep the information fresh and to understand the concept in depth. Join, relationship, and union. They seem the same, but they are totally different, especially join and relationship. Many people get confused about them, and many people couldn't differentiate between join and relationship and the difference between them. But union is already totally different, and the differentiation is very easy between union and the other two concepts. But what are the differences between join, relationship, and union? And when to use them? To understand that, we need to go back a little bit to the steps of data analysis. We already explained the steps of data analysis in details in the playlist of data analysis with Excel. This playlist is not only for Excel, but to understand the data analysis concepts in general. So if you decided to work with any other application other than Excel, you will understand and you know what is the concept of the data analysis. One of the steps in data analysis is data modeling. Data modeling, there are three types of data modeling: conceptual data model, logical data model, and physical data model. I will go over them quickly. If you need to know more information, I will put the link for the videos that explain them in details from the playlist of data analysis so you can know more, and this is highly recommended. Data modeling is to develop a data model. We have three types of data modeling: conceptual, logical, and physical data model. The conceptual data model is only general information about our system, the system that under consideration. We just draw a diagram about the system on a piece of paper to know what are the items included in this system, how they are related to each other. We don't go deep in information about this system. We just collect a general idea, a big picture of our system. For example, if we are working on a system for sales, we can expect, for example, we have customers, orders, and products. And also we need to know how these items are related to each other. For example, we know that customer orders and every order contains product. Just superficial information, just a general diagram about the system to have an idea or a big picture about the system without deep details. This is the conceptual data model. Then the logical data model have more information, more detail about the system. At this stage or at this model, we know what are the items included in our system, how they relate to each other, what are the tables included. For example, we have customers table, orders table, and product table. So we know the tables. We know also the keys, like the primary and foreign key, and the relationships. Let's say this is the customers table. This is the orders table. And this is the products table. There is a relationship between customer and orders and between orders and products. All of these are information that we know from the logical data model. Also, we know that the key in the customer table is, for example, customer ID or customer code, and this key will be foreign key in orders to know which customer have ordered these orders, and also the product code in product. So at the logical data model, we know the tables, the relationships between tables, the keys, primary and foreign keys in every table. And the difference between primary and foreign key, primary key is the unique identifier of each table. For example, customers, the unique identifier will be the customer ID because we will write it once. We will not duplicate the customer ID in the customer's table. While the unique identifier for the orders will be the order ID. So it won't be duplicated over the orders table. While customer ID inside orders is a foreign key that comes from customer to know which customer ordered this order. So it may be duplicated here. For the physical model, we go deeper inside uh, our data model, so we know more and more information. Like, for example, what are the other fields inside each table? What will be the data type of each field? What will be the constraints in each field? All of these detailed information are inside the physical model. If you remember, in logical model, I mentioned that there is relationship, right? So the relationship is in the layer of the logical model. As we know now, what are the differences between the three types of data modeling? We can now understand what is the difference between relationship, join, and union. Before we return back to these three concepts, in Tableau, there is no representation of the conceptual model. But in Tableau, we have a logical layer and a physical layer. And we will see that inside Tableau. Let's go back to our main concepts. First, the join. Join and relationship seems very similar, but they are not. A join is in the physical layer. We will add join on the physical layer in Tableau, while relationship is in the logical layer. This is the main difference between join and relationship. What else? The most important thing between join and relationship is how Tableau will treat tables after setting a join or relationship. For example, if we have customers table and orders table, if we link them with a join, in this case, Tableau will create a third new table that contains all data, all fields from both tables. For example, if I have customer ID, customer name in customers, and order ID, order date, and order total in orders, in this new table, we will find the customer ID, customer name, and all the fields related to customer together with order ID, order date, and order total in a table, in a third new table. This is totally new table. So in case of join, Tableau will collect all the fields from the two tables in one new table. But if we created a relationship between customers and orders, Tableau won't create a third table. Will keep the two tables separated. Then, what will happen if I requested to build a visualization? In both cases, in the case of join, if I need, for example, to build a visualization to show me the total sales of each customers or the totals of the order of each customers, in this case, in the case of the join, Tableau will get the information directly from the third combined table because it has everything. Normally, the customer name in the customers and the details of the order in the order from two tables. But because of the join, Tableau already created a third table, and it will use this table to make a query to build the visualization. While in the case of relationship, Tableau will keep the two tables separated. And when I need to build a visualization that is based on a query from both tables, like for example, the same example, customer name and orders, Tableau will go to grab the orders detail, and using the customer ID that exists inside the order, it will take this customer ID to go to the customer table to see this customer ID refers to which name. This is the way a Tableau will work in both join and relationship. And that's why join in the physical layer, because the physical layer is deep dive, has more detail. And that's why this table has more detail, has both detail of the two tables. While relationship in the logical model, because it's less detailed, it doesn't need to collect the two tables in one table. It will keep them separate. What about the union? Union is totally different. Let's consider we have many entities of the same item. For example, here, if you look at my data, we have customers table. This starts from customer number 12 to the end of the rest of the customers, and all the customers that are from customer ID 1 to customer ID 11. So I have two tables of customer. What if I need to combine these two tables into one table that contains all the customer data, old or new customers or current customers? In this case, we use the union, which means union is to append data to a table, append data from two tables or more together. For that to happen, we need all the tables that I need to union to have the same structure. For example, if we look here at the customer, we have customer ID, customer name, phone, address line 1, and the address line 2. We have the same detail in the customer, all the customer. And what will happen is that Tableau will take all of these customers and append them to the other table. So we will have a table with all the customers. This is very important because sometimes when we do data analysis, we get data from many sources. Consider you have many orders data and you collect data from many branches. You get a table of orders from each branch. Or you have a table of order for each month, and you need to collect all the orders together. In this case, you will need to use union to make only one table to gather all of the orders. We can say that union, we can consider it as vertical link or vertical combination of the tables, because we add vertically, we add rows together vertically, ends up with one table. While join and relationship is a sort of appending horizontally. We append fields together from different tables and it's not important to have the same structure. We need only, in case of join and relationship, we need only to have a key in one table and a similar key in the other table, a field with a similar field. So customer ID here, and we need to a customer ID in the second table, order ID in one table and order ID in the other table, and so on. Now we need to see how we can do that practically on Tableau. Let's move to Tableau. Here in Tableau, we have our data set, and here are the sheets that we saw in the Excel file. Every sheet has a table. We have customers, all the customers, product line, and sales. The sales is the central table because sales has product and customers ID. I will drag and drop the sales data here in the workspace. And now this table is in the logical layer. This is the logical layer. How do I know that? Point to your table. Can you see the hint, the tooltip stating that this is a logical table and its name? So if I need to move to the physical layer, I will double click this table. Now I have the same sales data sample, but in the physical layer. In this physical layer, we have more details. And in this physical layer, we can join this table with another table. I close to return back to my logical layer. Now I need to create a join. To create a join, I will need to drag the other table to join to the workspace. But if I drag it here, it will be on the logical layer. And the logical layer is for relationship, not for the join. So before I create the join, I have to double click here to open the physical layer or to open the table in the physical layer. Then I need to join the customer with the sales data sample. I will drag it and drop it beside the table, Once I do that, I will see the two tables now with this join. This is the symbol of the join. And if we go down to the data to check the data, we will see the customer details added to the table, like the customer ID, customer name, and from here you can see the name of the table, which is customers, together with the sales data. And here is the name of the table for the sales data. So the two tables are combined together. All the fields are gathered in a new table. This is a third new table. And this table, Tableau will use when you query for data for visualization. And if you look here, you can see sales data sample is made of two tables. If I click inside this join, this prompt will open for the join. And from here, you can see the data source or the main table, which is the sales data sample. And here is the ID or the key is the customer ID. And from the customer is also customer ID. So customer ID linked to customer ID. Customer ID from sales data from the original sales data table is linked to the customer ID in the customers table. And Tableau correctly finds the correct fields. If you need to change the field, you can click here, and here you can see all the fields in this table, in the sales table, and here you can see all the fields in the customers table. You can choose whatever you need, but here we need customer ID to be linked to or joined to customer ID from the other table. What about these? These are four types of join. We have four types of join. When we use join, we name tables as left table and right table. The inner table will use the match data. Like, for example, the sales that have customers from the customer table, not all the sales. So if I have a sales data without a customer, it will not be involved in this table. If I have a customer without a registered order, it will not be included in this table. So only the intercept, the data that exists in both tables. The left join will grab all the data from the left table, even it doesn't have a match with the right table. For example, it will grab all the sales data, even if some of them don't have any customer data or any customer ID. And the customer data that only have sales. But if I have a customer, for example, if I have customers from customer ID 1 to 10, if customers numbers 1 to 9 have orders and the customer number 10 has no orders, all data from customers will be grabbed from customer 1 to customer 9, except customer number 10. This is the meaning of left join. Right is the same, but from terms of customers. So it will grab all data from the right table and only the data that match from the left table. So any sales data that will be, the Tableau will grab all sales data that only contains the customers inside the customer table, and will grab all customer data even if the customers don't have any sales. Full outer join will grab all the data from both tables, regardless whether they are matched or not matched. Matched data and non-matched data. So you can choose the type of join according to your needs and according what you need to see in your query. I will go back to inner join. I want to get rid of these. I will drag and drop the customers here and close this physical layer. I went back to the logical layer because I need to create a relationship. Now you can see this table is only the sales table without the customer details because there is no join. But what if I need to create a relationship? I need to create a relationship between the customers and sales. So I will drag the customer beside the sales. And here is the relationship. And now you can see only customer details. And if you want to see sales deal, you have to switch between them. We couldn't see full customer detail from it with the sales data. We can see the original customer ID only that is used for the relationship. Now I can switch between each table separately. Here you should see the relationship detail. If you don't see it, you can go from here, and below the relationship, you can click the relationship to see more detail and more information about the relationship. I will just make like this so I can see all the information about the relationship. You can also move with the scroll bar. From here, you can see which field is linked to which field. From sales data sample table, we have the customer ID related or linked to customer ID from the customers table. You can also change the field from here, but actually Tableau has grabbed them correctly. If you need to make another relationship between the same two tables, we can add more fields and select the field to make a relationship from the first table and the second table. But this is not our case. I will delete this. We need to expand performance options. And here in performance options, we can see cardinality. Cardinality is a type of the relationship. between these two tables. And the type of relationship will guide Tableau how to grab data, how to search data to grab them for your query. If you open any of them, you will find many and one. And here also many and one. So what is the difference? Now the relationship is many to many, which means any order, any sales data can be done by many customers, by one customer or more, and each customer can have sales data or order, one order or more. This is the meaning of many to many. One to many means that every sales data record, or in other terms, in other words, every order can be done by one customer or more. If I change this many and here to one, it means each one customer can order one or more orders, but a single order is done by only one customer. This is very important to guide Tableau while searching to grab data for query. For example, if you need to build a visualization to show total sales for each customer by names, by customer name. And this is a relationship. Tableau will grab the sales data from the sales data table, and then by the customer ID, it will take the customer ID and go to the customer table to search for the customer by ID. For example, if I get sales for customer number 10, it will take customer ID 10 and we'll go to see where is customer ID 10 to see the other details like the name. If this is set to 1, Tableau will stop searching once it gets this customer detail. So, for example, if you have customer number 10 for some sales data, Tableau will keep searching in the table until it finds customer number 10, and then it will grab the customer name and will stop searching. But if I set this to many, it means after grabbing the sales data, for example, for customer number 10, for example, Tableau will take the customer ID, which is 10, and go to the customer table, and there will search every record for customer number 10. When it finds a record with a customer ID 10, it will grab the data. It will grab the data, the related data to this customer ID. But after that, it will keep searching because it may find another customer ID with number 10, because this is many, which means you may find many customers to the same order. So if you set it to many, it means Tableau will search until it finds the first record of specific ID, and then will grab this information to the query. Then it will continue searching until the end of the table, the end of the records, to make sure that there's no extra customer with the name ID, with the same ID. But in the case of 1, if we set the customer to 1, Tableau will search for data related to the same customer ID, and once it finds the first record that relates to the same customer ID, it will stop searching. Now, we understood the difference between join and relationship, and what is the work strategy in Tableau if we set a join or a relationship, and what is the work strategy for each type of join and each type of relationship. That's great. Okay. What about union? Union is different, so we can easily differentiate between it. Now I have a table of customers and another table of all the customers. These all the customers have sales, and I need for sure to include them in my report to no historical data. So I need to union or combine this old customers table with the customer table. If I grab it here, it will set a relationship. But how can I set a union? When you come over the table, you will find this union. Come over this union until it turns orange, and you can just release it. You can see now this symbol means that this is union table, and when you point to it, you can see the table and the other tables that we use to union or to combine together. And when we go to the data, here our customer ID is 12. If you remember, we have all the customers were from customer number 1 to 11, while the customers table has customers starting from customer ID 12. If we move down, you can see that Tableau appends the data from all the customers table to the data from the customers. And if you go to the right, you can see the table name. Here, these customers come from customers table. If we go down, so these customers come from all the customers table. So it only append rows. But it's very important for union. If you need to union tables, these tables should have the same structure. Because as you see, Tableau uses one header and append data according to the header, to the column header. So I will remove this and add it again. Then I will open the physical layer for this customer and to union all the customer with the customer in the physical layer. So I will do the same, drag. If I put it here, it will create a join, but I need to drag it over and put it over the orange portion. And now you can see these two lines mean that there is more than one table combined together. And it will do the same. If I click here, you can edit the union. Once we choose edit union, we get this prompt to ask us how we want to apply the union. We have two ways to create a union, either by specific or manual, or to create it automatically using the wildcards. The manual is what we have done already. We drag the table over the other. While automatic, this is helpful in many cases. For example, consider you have many order tables from many branches for many months in many years. Consider you have 3 years of sales and you get the data as orders for each month in each year. It means that you will get 36 orders tables. Is it logical to drag all the 36 over the other? Because you may miss one of them, right? And you will consume a lot of time. In this case, automatic is the best option for you. In this automatic tab, you can see where to search. This is the location in my computer where I grab my dataset. My dataset was stored in this location. And here you can search in sheets, in the same workbook, or in other workbooks by using a wildcard. For example, if I have many orders sheets, I need to combine them together in the same workbook. In this case, I will write the order and I will add a wildcard to compensate the missing letters. For example, if I am sure that all my sheets that I need to combine start with order, so I will write order and then asterisk as a wildcard. It means if you find any sheet named order with anything after, just grab it to combine. If you know that your files or your tables have the word order, but it may be in the middle. In this case, you can add another asterisk before the keyword. It means whenever you see order in the sheet name, grab it to combine. This is sheets within the same workbook. And from here, you can include or exclude. It means I need to exclude any sheet that doesn't have this word, but include any sheet that have this word. If you have your files in different workbooks, you can use this section. For example, I can write also orders, asterisk, or asterisk, orders, asterisk. Not only these options, but also I can expand my search to include the subfolders within this location. So if I have any other file related to this data that I need to combine inside a subfolder, in this folder, I can expand my search to include this subfolder. I can also expand my search to go a step up for the parent folder. Once I set these settings, I will press OK, and all the files with these keywords with these settings will be combined in one table. And that's it. I will just close this because this is not my case. That's all for today, guys. If you have any question, you can write it in the comments down below.